for part 2. So remember I said that I was breaking this section apart because it's kind of a long one, but we're going to now talk about parallel and perpendicular lines. So it says graph the equations y equals negative 2/3 x plus 2 and y equals negative 2/3 x minus 6 on the same coordinate plane. What do you notice? Okay, so we talked about graphing using slope-intercept form yesterday. Do you guys remember? So when I see y equals negative 2/3 x plus 2, so I'll circle it in blue and I'll graph it in blue. Remember, 2 is what's called the y-intercept, and that's where we always start. So we're starting along the y-axis at a height of 2, so go up to 2. And then the slope is negative 2/3. So show me with your hands, what does negative 2/3 look like? Does it go up like this, or does it go down like this? It goes down, right? So negative 2/3, so I'm going to go down 2, 1, 2, over 1, 2, 3. So my rise was negative 2, my run was 3. And I draw that line in. If I was a good teacher up here, I would have my ruler ready. Man, I forgot my ruler. All right, so it looks something like that. So now the other one is y equals negative 2/3 x minus 6. So what's my starting point for this one? 6? Negative 6, right? Negative 6. So go down to negative 6. 1, 2, 3, 4, 5, 6. And from there, we're going to have the same slope. Down 2 over 3. Down 2 over 3, like that. And we sketch it in.
They're parallel.
Exactly, they're parallel. Sorry. All right, so they're parallel lines. So what did we notice about the similar thing in these lines? What was the same for these lines? The slope, right? Does that make sense that if I have parallel lines, their slope would be the same? Think about ski slopes. If the slope of the ski slopes are the same, right, they would be like parallel. They'd be going up at the same rate, right? So that's what's happening. Okay, so number 2, it says graph y equals 5x plus 2 below, or 5x plus 1 below. So our starting point now is going to be positive 1. So start out with 1. Xavier will. And my slope is 5. So if your slope is 5, do you remember what we were doing yesterday? Yeah, we write it as 5 over 1. So our rise is up 5. 1, 2, 3, 4, 5, and over 1. So when we sketch it in, it's kind of hard to sketch in these really super steep ones and hit all those points. Still messed up. Looks like that. So it says if you are going to have a line that is perpendicular, in other words, it meets at a 90-degree angle. Do you guys all know what 90 degrees is? Perpendicular, like this, right? It makes like a T, like a sharp corner. Would its slope need to be positive or negative? So look at this. It would need to be negative. Do you guys see that? It would need to be going down. Would it need to be steep or shallow? Yeah, it'd have to be the opposite. So this one's super steep. So if I drew one that was also super steep but negative, that doesn't help us. That doesn't look like a 90-degree angle here, does it? Do you guys get that? Okay, so I basically need it to be the opposite. I need it to be a negative slope, but it also needs to, instead of being steep, it needs to be very, very shallow. Okay, any guesses as to what the slope will be? Does any of you know already?
Y equals negative 5x minus 1.
So if you have negative 5x, and then you start out negative 1, is that what you're saying? The y-intercept doesn't matter. But if I had negative 5x, I could go down 1, 2, 3, 4, 5, and over 1. And that just doesn't quite work, right? It's not 90 degrees. So that's what we're talking about, the steep versus shallow. Yeah, Maya? Ah, yes. So she says it's the opposite. It's like instead of 5 over 1, it's 1 over 5. But it also needs to be negative. Do you guys understand that? So let's say we're going through the point 0, 1 again. And I go down 1 over 1, 2, 3, 4, 5. And I could go the other direction too. I could go up 1 over 1, 2, 3, 4, 5. 1, 2, 3, 4. And I end up getting this line like this. Does this look like a 90-degree angle? Yeah, it does. You guys see how those look perpendicular? Yeah, so they're perpendicular. So basically we need the slope. Our new slope, instead of having 5 over 1, we need 1 over 5. And instead of being positive, it needs to be negative. Okay, so we call that the opposite reciprocal. Opposite means plus goes to minus or minus goes to plus. Reciprocal means you flip your fraction over. Okay? All right. Let's try a couple more. So it says parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. So I've created this little table here. So let's say our original slope is negative 2/3. So if it's going to be parallel, we have the same slope, right? So it's also going to be negative 2/3. But if it's perpendicular, we flip the fraction over and we make it the opposite sign. So instead of having 2/3, I flip it and make it 3/2. And instead of being negative, it's going to be positive. Sarkis' phone on my desk again. Man, this is strike 2. Strike 3, I give it to Dave. You don't want that. All right, 3/4. So if I have 3/4, what's my parallel slope?
3/4.
3/4, same thing, right? What's my perpendicular slope? 4/3. Like that? Done? Negative, right? Opposite sign. And then 10. Yeah, think of this as 10/1, so it's still 10/1. The perpendicular flips, yeah, so it's 4/3. Did I say 3/4? I probably did. Yeah, it's 4/3, thank you. And then it's going to be 1/10, and it's negative, right? Do you guys get that? All right. So parallel, same slope, perpendicular, you flip the fraction, and you make it the opposite sign, okay? So it says graph the line y equals negative 5x plus 6 on the coordinate plane below. So again, starting point 6. So start up at 1, 2, 3, 4, 5, 6. My slope is negative 5. So negative 5, I go down 1, 2, 3, 4, 5 over to the right 1. So that way it's going downwards in the end like I want. Okay, you can draw this in. Oops, went around something.
How do you know how to go over 1?
I know I want it to be, the slope is negative 5, so it's the same as negative 5 over 1, like that.
Okay.
And then we want the line that's parallel to this with a different starting point. It says through the point negative 2, 3. So let's start with negative 2, 3. So negative 2, up 1, 2, 3. So we're in the second quadrant. So left 2, up 3. And we want to be parallel. So if we're going to be parallel, we have to have exactly the same slope. So we still need the slope of negative 5 over 1, right? So I'm going to go down 1, 2, 3, 4, 5 over 1. And if you do it correctly, you'll end up getting parallel lines. It is kind of tricky, though. Sometimes you draw it in and it's like, whoa, those are a little bit off. But it's because it's hard to draw in straight lines.
Wait.
I'll get rulers out for you, too.
So it doesn't matter like how far away you put the parallel line, as long as it's parallel. It's okay.
Yeah, so I could have said any starting point. I could have said that like negative 10, 0, and then I could have gone down 5 over 1, right? And that would also be a parallel line. So it doesn't matter what point it goes through, right? So in this case, I said it was going to go through the point negative 2, 3. So that's why I drew it where I did. But it doesn't matter. There's an infinite number of parallel lines, right? It could have gone through any point. All right, so this one. So it says graph the line through 3, 1 that's perpendicular to the line with the equation 1/2 x minus 5. So I'm going to go down 1, 2, 3, 4, 5. And my slope is 1/2. So I'm going to go up 1 over 2, right? Over to the right 2. So in the end, it's a positive slope. I'm going upwards. You can draw a couple different points if you need to. And we draw the line in. And this one says we want to be perpendicular to the line with the equation 1/2 x minus 5. So we want to have what slope? Yeah, we want it to be negative 2 over 1, exactly. And then now we want it to go through the point 3, 1. So go over 3, 1. And our slope is negative 2, 1. So we want to go downwards in the end. So I could go up first, but then I would go to the left, right? So I usually go down 2, right 1. Down 2, right 1. Unless I run out of room on my graph, and then I go up 2, left 1. Just as long as it's a negative slope in the end. Okay, and then we check. Does it look like it's perpendicular? No, you're fine. Don't worry about it. Perpendicular? Yep. 90 degrees, right? It works. 90 degrees is like the edge of a paper. Like that's 90 degrees, right? So I can put a little piece of paper up against it. You guys can check with yours even. Take a little piece of paper, put it up against it. Does it make 90 degrees? Yep. Fits that spot. All right, feeling pretty good about this? Yep. All right, so graph the line through 1, negative 2. That's parallel to the line with the equation 4x minus y equals negative 2. So now it's not set up in the same way. So when I look at 4x minus y equals negative 2, I can't be like, oh, the slope is 4, right? I don't know what the slope is. The slope actually is 4 in this one, but you can't identify the slope in this form. Why? Yeah, what do you think, Ryan?
Well, I was thinking the slope was going to be -1.
Yeah, you think it's going to be -4. It
Oh,
actually,
right.
when you divide by -1. So are you trying to do all the steps in your head to solve for y?
Yeah.
Yeah, exactly. You need to see it in the form y equals mx plus b. Yeah.
Oh, that was
Oh, you were on it. All right. So we want y equals mx plus b form. Okay, so if I have 4x minus y equals -2, the first thing I'm going to do is I'm going to subtract the 4x over. So I get negative y equals negative 4x minus 2. And I want just y, not negative y. So I'm going to divide by -1, divide by -1. So I get y equals 4x plus 2. Remember how I was doing that like silly heart? And I was like, oh, that -1 goes into both things. Right, that's what we're doing. So the -1 went into both things. And I had a positive 2. So let's go ahead and graph that line. So I have y equals 4x plus 2. So I'm going to start at 2. And I'm going to go up 1, 2, 3, 4 over 1, right? Because my slope is 4, which is really 4 over 1. My y-intercept, the b value, is 2. So I started at the starting point of 2. I went up 4, right 1. So that's the original line. And then our new line, we're going to go through 1, -2. So 1, -2 is in the 4th quadrant. Write 1 down 2. And we want to be parallel, so we want the same slope, right? So when it says parallel, same slope. So we're still going to go up 4, right 1. So up 4, 1, 2, 3, 4, right 1. And we draw it in. And they should look parallel in the end. So mine are pretty good. All right, so that's the new line. And you don't have to label them. I'm just doing it for your notes. Okay. Still doing okay? We like this section? How are you guys feeling with graphing lines? Are you getting better at them?
It was good until the homework.
Ah, you tried the homework and you had trouble. All right, so what if we don't have a grid? Well, let's do one last with a grid. Okay, so it says write the equation of the line that's perpendicular to y equals 6 through the point -5, -3. So when a lot of my students that are in like Algebra 2, pre-calc, and so on, when they see this, they know immediately. So they say right away, they're like, oh, I know the answer, it's this. Okay, think about it. So what does the line y equals 6 look like? Does it look like a horizontal line or does it look like a vertical line?
Vertical.
It is not vertical. Everybody always thinks y-axis. It's horizontal, right? Because y equals 6, every y value equals 6, right? So I could have 0, 6. I could have 1, 6, 2, 6. I could have all those points. So 0, 6, 1, 2, 3, 4, 5, 6. 1, 6, 2, 6, 3, 6, -1, 6, -2. Do you guys see how it creates a nice horizontal line? I could have 1/2, 6, 1/4, 6. So this is a horizontal line. So if I want to be perpendicular, what type of line does it have to be? It has to be vertical. Does that make sense? If you're going to be 90 degrees, like meeting at 90 degrees, it has to be the vertical one. It can't be a slanty one because then it's not 90 degrees. So it has to be a vertical line. And we're going through the point -5, -3. So 1, 2, 3, 4, 5, 1, 2, 3, done. So I'm in the 3rd quadrant. So if I'm going to be a vertical line going through that point, is it x equals? Is it y equals? What is it? X equals, right? And what's the x value for each of those points? -5. So let's think through, like without drawing this, are we like smart enough to figure this out? Like in the snap of our fingers. Like, can we get this right away? Yes, you are. You will be. All right, so when it says perpendicular to a y equals equation. So show me what a y equals equation looks like with your hands. Y equals looks like this. If you're going to be perpendicular, it's going to be like this, right? Is that an x equals or a y equals? It's an x equals. X equals is vertical. Looking at the point that you go through, what's its x value? -5. So it has to be x equals -5. So Does that make sense? So what if I said parallel? What if I said parallel to a y equals? Would it be x equals or y equals? It would be also a y equals. Yeah, Ryan?
I was just going to say, if you graph the point on the graph and then just drew a line on
Yeah,
that.
that's fine. Yeah, if you knew that it was going to be a y equal, like an x equals, and then you drew it. All right, so number 5. So without graphing, find the line. So if it says parallel to x equals 3, so if it's parallel, that means it's the same, right? So it's also going to be an x equals equation. So what x value do we have as our point? -1, right? So our answer would be x equals -1. How about the next one? It says perpendicular. Oops. Perpendicular to x equals 3. So if you're perpendicular to an x equals,
Y equals
it's a y equals. What's the y value? 8. You guys see what I'm doing there? All right, what if it says perpendicular to a y equals equation? Y equals equation, it looks like this. It's horizontal. So perpendicular is going to be an x equals. What's the x value? Yeah, -4. You guys see the pattern? So the next one says parallel to y equals. So y equals is a horizontal line, sorry. And then through -7, 6, also a horizontal line. So what's it going to be? Oh, whoops, I circled the wrong thing. You are right. I'll give you a bonus point for that. You got me. I was on it. Yeah, so it would be a y equals, right? It's the same as whatever it was. So if it says parallel, it's also a y equals. If it said perpendicular, it's the opposite, okay? You guys get it? No? All right, you want to do a couple more?
Yeah.
So what if it says parallel? This is the symbol for parallel. Do we see why it's the symbol for parallel? So what if it said parallel to y equals 7 through 0, 15? So is it a y equals or an x equals? That's what we decide. No, it's parallel. It's going to be parallel, so it's going to be the same kind of equation. So it's going to be y equals 15. But if it said perpendicular to y equals 7 through 0, 15, perpendicular to a y equals equation would have to be the x equals equation, right? So what's the x value here? 0. So it'd be x equals 0. Now do we get it? All right, we'll let it simmer. Give it a few minutes. You'll be like, oh. All right. So last little bit. So it says find the equations of the lines with the following characteristics. So we're going to actually start from the beginning without graphing it, come up with an equation. So it says with a slope of -2/3 through the point 0, 6. So a slope of -2/3. So we're going to write our y equals mx plus b, and we're going to identify what each thing is. So what's -2/3? What does it replace?
M?
M. How about 0, 6? Is that anything?
No.
We don't know. Okay, it actually is.
It could be the x and
Yeah,
y-intercept.
it is the y-intercept. Why does it have to be the y-intercept? Nell, do you have it? Yeah, it's an ordered pair, and it says go over 0, up 1, 2, 3, 4, 5, 6. Do you guys see how that would be the y-intercept? Right, but if you didn't know that, that's totally fine. So you would start out this equation and you'd be like, okay, I'm going to replace the m with -2/3. And then if you didn't know what the b is, it's okay, because you can always plug in for x and y temporarily to find what b is. So you would plug in your 0 and your 6, and you'd be like, okay, I have 6 for y, I have 0 for x, and then I'm finding my b value. So I get 6 equals b then. And then you just rewrite your final equation with the m and the b. But x and y go back to being x and y. So it's going to be y equals, the m was -2/3 x plus 6. So really this point right here, this was the y-intercept. But it's not always the y-intercept. In this case it was, because it started out with a 0. So it was 0, something. Okay, do you guys see that? So you can kind of shortcut it and you don't have to plug in for x and y. You can just know, oh, b is going to be 6 then. So we'll do some more like that. All right, so it says, well, what if we have a slope of 1/2 through the point 4, -8? So is -8 our y-intercept? No, because we have 4, -8, right? So it can't be our y-intercept. All right, so we start out with our y equals mx plus b. And we're like, okay, well, I know my m. My m is for sure this 1/2. So I'm going to replace my m with 1/2. So I have y equals 1/2 x plus b. but I don't know what B is. So if you want to find B, we temporarily plug in something for x and y. So any point on the line will work. So what point is on the line? 4, -8, right? So I'm going to do -8 for y. So you can call that x comma y if you want to. And then I'm going to do 4 for x, right? So I get 1/2 of 4 plus b. Okay, so what's half of 4? 2. -8 is equal to 2 plus something. So we subtract the 2. Subtract the 2. Do you guys see it's -10? -10 is equal to b. So once you have your m and your b, you're good. We can write our final equation. So our final equation is y equals m, which was 1/2, x plus b, so minus a 10. So we just plug everything in. Does that make sense? So the next one, parallel to the line y equals 4x minus 5 through the point -1, 0. So if we're going to be parallel to this line, what is my slope? Parallel means same slope, right? What's the slope of that line? Y equals 4x minus 5. What's the m? 4, right? So the 4 is in front of the x, right? So 4. So we use the same slope. Everything else in this line we totally ignore. So whenever I've taught this in the past, what I have my students do is just cross out everything else that's in that line. So the only thing we're worried about is that slope of 4. And this goes back to what AJ was talking about when he was talking about that parallel line. Do you guys remember when we were talking about this one? And he was like, well, could you have other parallel lines? Yeah, you could have a parallel line here, here, here. There could be lots of parallel lines. I did not draw those parallel. So the only thing that matters from that is the slope. I don't care where the y-intercept was. It doesn't matter. But I know that this new line goes through this point, -1, 0. So now we say, okay, well, I have y equals mx plus b, and I know my m is going to be 4. So temporarily, I'm going to plug in my -1 and my 0 for my x and my y. That allows me to find the b value. Why is -1, 0 not the y-intercept? Think about where you would plot that. What kind of intercept is it? -1, 0, it's over here, right? It's the x-intercept. So x-intercepts we don't use in that y equals mx plus b. All right, so I'm going to temporarily plug in 0 for my y, -1 for my x, and I'm going to solve for b. So go ahead and try it. Try to solve for b. That's our keys. So I get 0 equals -4 plus b. I add the 4 to both sides. So I get 4 is equal to b. So my final answer has m and b in it. What was m? 4. What was b? 4. So y equals 4x plus 4. Okay, are you guys understanding this? Kind of all. Parallel and perpendicular?
I know what they are. but like.
So when you see it, you don't always know what to do. So when it says parallel, you use the same slope. You get that, right?
Yeah.
When it says perpendicular, use the opposite reciprocal. So kind of go back to this x and y thing that we were talking about. What is the slope of a y equals equation? So y equals looks like this, right? So what's the slope of that line? Do you guys remember my story about the skier? My friend Sarah? What's the slope of a horizontal line? 0. What's the slope of a vertical line? Undefined, right? So the slope here is 0. If you do the opposite reciprocal, for this one we get -1 divided by 0. Right, we flip it. So instead of a 0 over 1, it becomes 1 over 0, opposite sign. -1 over 0 is undefined. We cannot divide by 0. Okay, it's illegal. We don't do it. So that's why this one is undefined. Is that what you're asking about? Kind of talking about? All right, so that's why these ones are just quick ones. We don't worry about what the slope is. We just say, oh, it's an x equals, now it's a y equals. Oh, it's an x equals, and it's parallel, so it's also an x equals. All right, so how about this one? So it says perpendicular to the line y equals 3/4 x minus 7. So AJ, what's the slope of the original line? So the slope of this line right here. So what is my new slope? So I don't use anything else from that line. I just use that new slope. So you can cross out everything, really. You're like, okay, I have my slope. I'm not going to use that line at all. So now you're going to have y equals mx plus b. And you look and you're like, where I did the opposite reciprocal. So flip it over, because it says perpendicular. So flip it over and make it the opposite sign. So we always do a quick check. We're like, oh, do I have a y-intercept? No, I have -8 comma -4. That's not a y-intercept. That's in the third quadrant, right? Negative and negative. All right, so now we temporarily plug in for x and y. Well, let me put the m in. So we have -4/3 x plus b. So we temporarily plug in x equals -8 and y equals -4 from this point. I know I said points, through the points. Okay, so I get -4 equals -4/3 times -8. Oh, this was not nice of me. Plus b. We're going to go with it. Because we like fractions, don't we? I always look at Caitlin when she says something about fractions. She hates fractions, I don't know why. We like fractions, don't we, Cameron? Like it was like, no. All right, so here we go. So -4/3 times -8. So let's put -8 over 1. We get 32/3, right? So if I'm solving for b, I need to find -4 minus 32/3. Ooh, kind of hard. Any ideas on what I do? Ryan, do you have any ideas? Pretty good with fractions. Xavier, what do we think? How do I find -4 minus 32/3 without using a calculator? Yeah, what do you think?
You could get a common denominator.
We get a common denominator. We multiply by 3/3. So we're like, okay, well, I have -12/3 minus 32/3, which gives me -12 minus 32, -44/3. Do we see it? So when we write y equals mx plus b, we now know our m and our b. So it's going to be y equals -4/3 x minus 44/3. That would not be a fun one to graph. Because 44/3, ooh, what would that be? I don't even know. It'd be 14 2/3. That wouldn't be fun to graph. Got a little messy over here. You guys see it?
We have one that hard on this.
Oh, I do that in algebra too, but I probably wouldn't do it to you in algebra 1. I'll be nice. But you should still, fractions are your friend. You should know how to work with fractions, even if I do throw you one like that. All right, so this next one. So it says perpendicular to 2x minus 5y equals 10. These ones are the hardest ones. What makes this one difficult?
Perpendicular.
It says perpendicular. Now, what do you think? Yeah, it's not in the form y equals mx plus b. So we need to get this in the form. So get in form y equals mx plus b. So if I have 2x minus 5y equals 10, so go ahead and practice. See if you can get the y by itself. Try it along with me. Active note takers, right? Subtract your 2x, subtract your 2x. So we get -5y equals -2x plus 10. Divide by -5, divide by -5, and that -5 goes into both pieces. So we get y equals 2/5 x minus 2. There is only one number that is important to us in that. So most of it doesn't matter. The 2/5, right? And it said perpendicular. So when I see that 2/5, my new slope is m equals 2/5? -5/2. You flip it, make it the opposite sign. So it's -5/2 because it said perpendicular. All right, so we continue to solve. So we're like, okay, well, if I have y equals mx plus b, and I plug in m is -5/2, I want to find what b is. You could do too much. You could waste a lot of time on your homework if you don't look for things like this right here. 0, 4, if I plotted it, It's right there. What does that tell us? That's the y-intercept. Our y-intercept, b, is equal to 4. So we can just erase that b and easily and quickly put in a 4. Okay? Not from the start, because that was our original equation, had nothing to do with that y-intercept. Okay? So you had to find the slope first, and then you plug in the b. All right, that's about as hard as they get. Can you handle that? No. This worries me.